In this video, I'll be solving both an energy and momentum problem and explain in depth how they will be solved. So from the energy set, I chose question number 1, which is to solve at what angle the marble loses contact with the soccer ball with a radius r, and what the graph should look like of a normal force with position. So in the free body diagram, we can see that there are only two forces acting on the marble, which include both mg and fm. The free body diagram shows the marble as it is falling off and what happens during this entire process. So in order to solve for the radius, I first began by finding two equations. The first equation that I found was mg cos theta equals mv squared over r plus v, since the marble had no constant with the soccer ball, since fm equals to 0, and this is how I found this equation. As well, we can see that the marble is not in contact with the ball at this point. So the second equation that I derived was mv squared equals 2mg r plus v 1 minus cos theta. So since initially we were supposed to find at what angle the marble loses contact with the soccer ball, I basically substituted equations 2 into equation 1 and solved for what the angle was. I canceled out different variables and I came to the final conclusion that the angle was 48 degrees. So here is an image of the graph that I created of the normal force with position for the marble and the soccer ball. And as you can see at the bottom we have the rotation angle and on the side we have the fm. So for the momentum question, I chose problem number 3, in which we were supposed to find the initial speed of the bullet and what the slight car jump meant. So in order to solve this, I first began by looking at the video and collecting the information that was provided. I was able to find out that the mass of the cart was 0.3729 kilograms. The mass of the M&M was 0.002350 kg. The distance that the cart traveled was 0.15 meters, and the difference in the time frame. So since both the masses had the same velocity at the end, it showed that it was an inelastic collision. So using the formula that was provided to us, I basically plugged in the values that I had to solve for the initial velocity. And my final answer turned out to be 114.97 meters per second. So part B of this question asks, what does the fact that the cart jumps slightly up tell you? So what I realized is that the kinetic energy before the collision is converted into gravitational potential energy after the encounter occurs. So basically when the car jumps slightly up, it basically shows it changing into gravitational potential energy. This also shows that it's an inelastic collision because in this particular case, no kinetic energy is conserved. And lastly, the momentum in this system is conserved through the collision, as we can see through the video. Thank you for watching.